Welcome to the fascinating world of optics. Optics is a branch of physics that studies the behavior and properties of light, including its interactions with matter and the construction of instruments that use or detect it. From the simple act of seeing to the complex workings of fiber optic communication, optics plays a crucial role in our daily lives. Understanding optics helps us design better cameras, glasses, microscopes, and even advanced technologies like laser. In this video, we'll journey through the core concepts of optics, exploring how light behaves, how we manipulate it, and why it's so important in both science and technology. Optics is the scientific study of light, how it travels, how it interacts with different materials, and how it can be controlled and used. It's a foundational part of physics because light is everywhere. It lets us see, helps plants grow, and powers many modern devices. By understanding optics, scientists and engineers can create tools that improve our vision, help us explore the universe, and even transmit information at the speed of light. Optics bridges the gap between theory and practical applications, making it a vital field in both research and everyday technology. One of the most basic and important behaviors of light is reflection. When light hits a surface, it bounces back. This is what allows us to see ourselves in a mirror. The laws of reflection state that the angle at which light hits a surface, the angle of incidence, is equal to the angle at which it reflects off the angle of reflection. This simple rule explains why mirrors work and why we can see objects around us. Reflection is not just about mirrors, it's also why we see the world around us as light reflects off objects and into our eyes. Plane mirror is a flat, smooth surface that reflects light in a predictable way. When light rays hit a plane mirror, they bounce off at the same angle, creating a clear and upright image. The image appears to be the same distance behind the mirror as the object is in front of it. This is why when you look into a bathroom mirror, your reflection seems to be right behind the glass. Plane mirrors are used in everyday life, from household mirrors to scientific instruments, because they provide accurate and undistorted reflections. Refraction is the bending of light as it passes from one medium to another, like from air into water. This happens because light travels at different speeds in different materials. When you put a straw in a glass of water, it looks bent. This is due to refraction. Refraction is not just a neat trick, it's essential for the functioning of lenses, glasses, and even our eyes. Understanding refraction helps us design better optical devices and explains many natural phenomena, like why pools look shallower than they really are. Refractive index is a measure of how much light slows down in a material compared to its speed in a vacuum. Each material has its own refractive index, which determines how much light bends when entering or leaving it. For example, glass has a higher refractive index than air, so light bends more when entering glass. The concept of refractive index is crucial for designing lenses, glasses, and other optical devices. It also helps explain why diamonds sparkle so brilliantly. They have a very high refractive index. Lenses are transparent objects, usually made of glass or plastic, that bend light rays to form images. There are two main types of lenses: convex, which bulge outward, and concave, which curve inward. Convex lenses focus light to a point, while concave lenses spread light out. Lenses are found in eyeglasses, cameras, microscopes, and telescopes. By carefully shaping lenses, we can correct vision, magnify tiny objects, or bring distant stars into view. The science of lenses is at the heart of many optical instruments. Convex and concave lenses form images in different ways. A convex lens can produce real or virtual images depending on where the object is placed. For example, a magnifying glass uses a convex lens to create a larger virtual image. Concave lenses, on the other hand, always produce smaller virtual images. Understanding how lenses form images is essential for designing everything from eyeglasses to cameras. By adjusting the shape and position of lenses, we can control the size, orientation, and clarity of the images we see. Microscopes are powerful tools that let us see tiny details invisible to the naked eye. They work by using a combination of lenses to magnify small objects. The basic principle is to use a convex lens to create a magnified image, which is then further enlarged by another lens. This allows scientists and doctors to study cells, bacteria, and other microscopic structures. The invention of the microscope revolutionized biology and medicine, opening up a whole new world of discovery. Total internal reflection is a fascinating phenomenon that occurs when light tries to move from a denser medium to a less dense one, like from water to air, at a steep angle. Instead of passing through, the light bounces back entirely into the denser medium. This principle is used in optical fibers, which carry light signals over long distances with very little loss. Total internal reflection is also responsible for sparkling effects in diamonds and the bright lines you see at the bottom of a pool. Prism is a transparent object, usually made of glass, that can split white light into its component colors. This happens because each color bends by a different amount as it passes through the prism, a process called dispersion. That's why when sunlight passes through a prism, you see a rainbow of colors. Prisms are not just for science experiments, they're used in cameras, binoculars, and even in some types of lasers. Dispersion helps us understand the nature of light and the beauty of natural rainbows. Telescopes are amazing devices that let us see faraway objects like stars and planets. They work by collecting and focusing light using lenses or mirrors. The larger the lens or mirror, the more light the telescope can gather, allowing us to see fainter and more distant objects. Telescopes have revolutionized astronomy, helping us discover new planets, galaxies, and even the expansion of the universe. Whether using optical or radio telescopes, the basic principle is to gather as much light as possible and focus it to form a clear image. Optical fibers are thin strands of glass or plastic that transmit light signals over long distances. They use the principle of total internal reflection to keep light trapped inside, allowing data to travel quickly and efficiently. Optical fibers are the backbone of modern communication networks, enabling high-speed internet, phone calls, and even medical imaging. Their ability to carry vast amounts of information with minimal loss has transformed the way we connect and share information around the world. Interference is a phenomenon where two or more light waves overlap and combine to form a new pattern. Sometimes the waves add together, making the light brighter, and sometimes they cancel each other out, making it dimmer. This effect can be seen in soap bubbles or oil slicks, where colorful patterns appear due to interference. Interference is important in many technologies, including lasers and holography, and helps scientists understand the wave nature of light. Refraction occurs when light waves bend around obstacles or pass through small openings, spreading out as they go. This bending causes patterns of light and dark bands, which can be seen when light passes through a narrow slit. Diffraction is a key concept in understanding the wave nature of light, and is used in devices like diffraction gratings, which separate light into its component colors. It also explains why shadows are not always sharp, and why we see colorful patterns in CDs and DVDs. Polarization is a property of light that describes the direction in which its waves vibrate. Normally, light waves vibrate in all directions, but when light is polarized, the waves vibrate in just one direction. Polarized sunglasses use that principle to reduce glare from surfaces like water or roads. Polarization is also important in photography, LCD screens, and scientific research. Understanding polarization helps us control and use light more effectively in many applications. Cameras are devices that capture images by focusing light onto a photosensitive surface, like film or a digital sensor. The main principle behind a camera is the use of a lens to gather and focus light, forming a sharp image. By adjusting the lens, we can change the focus and zoom in or out. Modern cameras use advanced optics and electronics to capture high-quality photos and videos. Cameras are used everywhere, from smartphones to scientific research, making them one of the most important optical instruments. Optical instruments are devices that use lenses, mirrors, or other optical components to manipulate light. Examples include microscopes, telescopes, cameras, and even eyeglasses. These instruments help us see things that are too small, too far, or otherwise invisible to the naked eye. By understanding the principles of optics, we can design better instruments for science, medicine, and everyday life. Optical instruments have revolutionized our ability to observe and understand the world around us. Human eye is a remarkable optical instrument. It works by focusing light onto the retina, a layer of cells at the back of the eye that senses light and color. The lens inside the eye changes shape to focus on objects at different distances. Special cells in the retina detect different colors, allowing us to see the world in vivid detail. Understanding how the eye works has led to the development of glasses, contact lenses, and even artificial vision technology. Lasers are devices that produce a focused, intense beam of light. They work by stimulating atoms to emit light of a single color, which is then amplified and directed in a straight line. Lasers are used in a wide range of applications, from cutting and welding materials to reading barcodes and performing eye surgery. They're also essential in communication, entertainment, and scientific research. The unique properties of lasers make them one of the most versatile tools in modern technology. Optical technologies have both positive and negative impacts on the environment. On one hand, fiber optic communication reduces the need for energy-intensive copper wires, making data transmission more efficient. On the other hand, the production and disposal of optical devices can generate electronic waste. Advances in solar energy, which relies on optical principles, help reduce our reliance on fossil fuels. By understanding the environmental effects of optical technologies, we can make better choices for a sustainable future. One of the most intriguing questions in optics is whether light behaves as a wave or a particle. Experiments show that light has properties of both. It can bend and interfere like a wave, but also travel in packets called photons like particles. This dual nature is at the heart of quantum physics and helps explain many optical phenomena. Understanding this concept allows scientists to develop new technologies, such as quantum computers and advanced imaging systems. Optics isn't just for scientists, it's all around us in daily life. Glasses and contact lenses help millions see clearly. Cameras and smartphones capture our memories. Even simple things like mirrors, magnifying glasses, and projectors rely on optical principles. Streetlights, traffic signals, and fiber optic cables keep our cities running smoothly. By understanding the basics of optics, we can better appreciate the technology that shapes our world. Medical science relies heavily on optics. Instruments like endoscopes, which use fiber optics, allow doctors to see inside the body without surgery. Lasers are used in eye surgeries, dental treatments, and even cancer therapy. Microscopes help diagnose diseases by revealing details invisible to the naked eye. Optical imaging techniques such as MRI and CT scans provide detailed pictures of our internal organs. Optics has truly revolutionized healthcare and continues to drive medical innovation. Entertainment industry uses optics in many creative ways. Movie projectors, stage lighting, and special effects all rely on the manipulation of light. 3D movies use polarized glasses to create the illusion of depth. Lasers are used in concerts and light shows to dazzle audiences. Even virtual reality headsets use advanced optics to immerse users in digital worlds. Optics brings imagination to life, making entertainment more vivid and engaging. Industrial applications of optics are everywhere. Lasers cut and weld materials with precision. Optical sensors monitor production lines and ensure quality control. Barcode scanners in stores use lasers to read product information. Even solar panels, which convert sunlight into electricity, rely on optical principles. Optics helps make manufacturing faster, safer, and more efficient, driving progress in countless industries. Nature is full of optical wonders. Rainbows form when sunlight is refracted and reflected in raindrops. The shimmering colors of butterfly wings and peacock feathers are due to interference and diffraction. Some animals, like cats and owls, have eyes specially adapted to see in low light. Even the blue sky and red sunsets are explained by the scattering of light in the atmosphere. Studying optics helps us appreciate the beauty and complexity of the natural world. Future of optics is bright and full of possibilities. Advances in photonics, the science of using light for information processing, are leading to faster computers and more secure communication. New materials and nanotechnology are enabling the creation of ultra-thin lenses and invisibility cloaks. Optical sensors are making self-driving cars safer and smarter. As we continue to explore the potential of light, optics will remain at the forefront of innovation and discovery. Despite its many successes, optics faces challenges. Making optical devices smaller, cheaper, and more efficient is a constant goal. Reducing the environmental impact of manufacturing and disposal is also important. Scientists are working to overcome the limits of current materials and develop new ways to control light. By addressing these challenges, we can ensure that optics continues to benefit society and drive technological progress. Optics is a dynamic and essential field that touches every aspect of our lives. From the way we see the world to the technologies that connect us, the study of light and its behavior has led to countless innovations. By exploring concepts like reflection, refraction, and polarization, we gain a deeper understanding of both nature and technology. As we look to the future, optics will continue to illuminate new possibilities and inspire the next generation of scientists and inventors.